we'll look at that stuff together once all the tests are in, but of course the test is the most important, so don't feel rushed. I'll put it on your desk. I'm pretty sure. Took that pile of papers you had on. You had a pile of paper in your desk. I think I put one on the top. Yeah, that's it.
You. Six. Alright, it looks like that's all of the test. So, I'm going to give you just a minute to finish up what you're looking at if you were working on something for another class. And then we need to talk about the next unit and move that direction. So I left the handouts on the front desk, so if you didn't grab those on your way in, you do need to go get those. We're not going to have time to look at all three of these, but we'll have time to go over the first one, and the other two are just more practice on that. So we are finally finished with logarithms, and I don't know, I'm ready for a change, but I guess I have 3 pre-cal classes, you guys just have the one, so maybe I'm more ready to move on than you are. But I would say our next unit, I'd say the content's a little bit easier, at least for most people. But on the flip side, we don't spend as much time on it. So for the most part, we're going to spend roughly 1 full class period on linear stuff. That's what we're going to look at here in a second. So basically, stuff you saw in Algebra 1 with a couple other things mixed in that you may not have seen. Basically 1 day on quadratics, basically 1 day on piecewise function, and then we'll have 1 day for review, and then we'll have a test. So again, easier content for most people, but a little bit quicker paced. So I'm going to go through all of 109 with you. That is worksheet 1, but if you glance at the one that's called worksheet 2, 110, it's basically the same questions, and then I will have you practice those to see how you do. But even though you should remember most of this, I'm still going to start you off with reminders and kind of emphasize the questions I think you've not seen before and highlight some of the stuff that I think is easier that you may not have done previously from algebra classes. Okay, so let's go ahead and look at this. Addie, you want to take your headphones out and join us? Okay, so the first 4 questions are asking about writing an equation of a line, and it describes 3 different formats. So let me talk about what it's referring to with the 3 formats. 2 of them are going to be really important, and the third one I'm perfectly happy if you never use it, and I'll tell you why. But the one I'm going to use all the time is called point slope form. I think most of the time you guys have seen this, but you don't have to use it maybe as much as you should. Point slope form, this is where you have a point and the slope. So slope is going to go in place of m, and the point given to you goes in for x1, y1. So basically, if you have a point and a slope and you know what that form is, you just plug the 3 numbers in and you're done. You have the equation of a line. The one you guys seem to love, but I think by the end of this worksheet I'll convince some of you this one's not as good, is slope-intercept. You still need to know this one, even though I don't think it's as good, because some questions will refer to that. And if we're doing stuff in the calculator, we want it to be in y equals. But that's the mx plus b, so you have to know the slope still, and b is the intercept, specifically the y-intercept. So sure, if you have the slope and the y-intercept, then slope-intercept form is probably going to be the easiest, although point slope is just as easy because y-intercept is just the point. Since this has 3, I'm going to go ahead and tell you what this one is, but this is point slope form. This is the one that's not really important anymore. It just has become less emphasized over time. But there's a general form where you put the number of x's and the number of y's on one side and the constant on the other side. Some people think this form's a little bit easier for finding x and y intercepts. If you want to know the y-intercept, you plug in 0 for x and solve. If you want to know the x-intercept, you could plug in 0 for y and solve. I think this has kind of come out of fashion, partly because in college, if you ever have a professor that likes things in general form, it just varies widely. Some people just like it to be in this form. Some professors want it to be in this form, but A needs to be positive. Some professors want it to be in this form. They want A to be positive and to be 1, so you have to manipulate everything a little bit. But personally, I don't think this one is near as useful as these. I think I use this one 99% of the time, and if the question specifically says point slope, or slope intercept, then I need to be able to refer to that. So the other thing I'm going to need for questions 1 and 4 is if I've got to know the slope, then we need to remember a couple ways to find slope. Slope, you're welcome to count rise over run. You have a picture, but usually the quickest, if you have 2 points, is to subtract the y values to calculate the rise, and then in the same pattern, subtract the x's to calculate the run. Now again, I know you have seen this stuff. I don't know if your Algebra 2 teacher focused a ton on point slope, but I know you've seen the slope formula before. Again, it's good for you to know, it's helpful for calculus, but also, even if you're not doing calculus next year, of course this stuff shows up on the ACT, so hopefully it'll be helpful for that. Okay, so with those reminders, let's look at question 1. So they want us to come up with an equation that goes through these 2 points. So again, I always just use point slope. Point slope is easier, and it's what we use all the time in calculus. I'll talk about how you can get point slope and the slope intercept, but that's always extra work, so calculus students don't do that after a couple weeks. They're not interested in doing even more work than they have to do. So, since it doesn't say what form, I know I'm going to aim for point slope. I just pick one of these points. You can really pick either one you want, doesn't matter. I'll just always pick the first point just for consistency. But the x value goes in for x1. Since this is minus a negative, I just change it to a plus. And I'm going to plug this in for y1. I'm almost done already with point slope form. The only thing I'm missing is slope. So the long way to do this is you could make a graph, you could plot this point, you could plot this point, and you could count rise over run if you really want to. But it's a lot quicker to just subtract the y values on top and then subtract the x values in the same pattern on bottom. It would be -3. Now, if you're just determined to put it in slope intercept, I'm not going to emphasize this more than just this question because I think it's silly, but if you really wanted it in slope intercept, maybe on the ACT all the choices are written that way, all you would have to do is distribute the -3 and then add the 6 over. So I don't know why you would insist on that form, but it's really always just going to be 2 steps. Distribute and add the constant over from the left side. Okay, so if we can do that question, we can do question number 4 because it also gives us 2 points. So again, I'm just going to pick one of these points, call him x1, y1, although you could use this point if you'd rather. Since it doesn't tell me what form it has to be in, point slope is the easiest to me. Plug in 5 for y1, plug in 0 for x1, and the last mystery to this question is what is the slope? So make a picture, plot the points, count rise over run, or even better, just use the slope formula and get 5/2. I guess the only thing I'd probably do in addition here is do that. Since -0 doesn't do anything, I probably wouldn't leave that as part of my answer. But okay, and again, I guess just one more question. If for some reason you're just insisting on putting your answer in slope intercept, you can still start with point slope and then just add the 5 over in this case. These two are saying the same thing. But again, I don't know why you would want to do an extra step, even if it's an easy extra step. So that would be my approach if you're given 2 points, and we'll need that for the rest of page 1 in just a minute. But For question number 2, I can't take the same approach. They only gave me 1 point, but they tell me that the line is horizontal. So there's a couple things we need to remember, and so you need to write down at least a part of this that is not familiar to you. You need to know the difference between a vertical and a horizontal line. Horizontal for this question, but vertical later on this worksheet. You need to know the slope of these. You could always just pick 2 points on a horizontal line, count rise over run, and you could figure it out in the moment. Same with vertical line. If you did rise over run, you would be trying to divide by 0. So we say it has an undefined slope. And one other thing that I think is a little bit helpful is to know what these equations look like. The equation of a horizontal line will always be y equals a number, whereas a vertical line is always x equals a number. So, question number 2, again, if I start off with point slope and I plug y1 in here, x1 in here, my last thing that I don't know is I don't know the slope. But since it's a horizontal line and we're supposed to know the slope of a horizontal line is 0, I really have all the information that I need. But 0 times anything is going to be 0, and you could add the 5 over and then notice it's in that format. All horizontal lines will be y equals a number. In fact, I could really just skip this. Horizontal lines always have the same y value. So if he's going through some point that has a y value of 5, his equation has to be y equals 5. But if you don't want to do that extra thought or know that extra information, you just plug in the information and solve. But you will need to know this for a few of the questions. So again, just write down the parts that you didn't remember. Okay, and then the last of these, number 3, throws one other curveball at us. So it does not give us 2 points like 1 and 4, and it does not tell us horizontal or vertical, but it still gives us a point. So I can still get most of the work done in about 5 seconds. Y minus the y value equals the slope times x minus the x value. All I'm missing is the slope to have my answer. If it wasn't for the slope, it would be a 4-second question. Alright, so what you need to remember for this question, and same thing, you need to write down the parts that you don't remember, is you need to remember a few things about parallel and perpendicular lines. So parallel lines never intersect, and the way that they never intersect is that they're going up or down at the same time. In other words, they have the same slopes. So if this had said parallel to this line, I would want to keep the slope the same. This guy has a slope of 4, so I would want to keep it a slope of 4. But it doesn't say parallel, it says perpendicular. So perpendicular lines are where they intersect at a right angle. And for that to happen, the slopes need to be are opposite reciprocals or negative reciprocals. Some teachers say negative reciprocals, some say opposite reciprocals. So we know what reciprocals means. Reciprocal just means you flip over the fraction. So 4, the reciprocal of 4 is going to be 1/4. But the opposite means opposite sign. If this was negative, I'd want it to be positive. This is positive, so I need it to be negative. So again, this guy has a slope of 4. So the opposite of that would be negative. The reciprocal of that would be 1/4. Making him have a slope of negative 1/4 when the other guy had a slope of 4 would make them be perpendicular. This is going to be just a little bit off on a tangent, but I do think this is interesting to some people, so let me grab these real quick. Just so you know that this is a a thing that you can do with your calculator. Okay, and then I need to add the 3 over. Okay, if you were to graph those two in your calculator, they're not really going to look perpendicular. I mean, this kind of looks like a right angle, but it's not a right angle. So if you were ever, again, I don't think this is going to apply to this class, but if you ever wanted to graph them both to see if they look perpendicular and you're like, oh, it's kind of close, but it's not right, the reason it doesn't look right is because your calculator has more pixels horizontally than it has vertically. So it has to stretch the image a little bit. If you ever really want to see it to be accurate, you can go to zoom. Instead of saying zoom standard, you can do zoom square. And that's where it tries to make the horizontal space the same as the vertical space. And then you can see these two do look perpendicular now. So again, it's just a zoom setting, so if you ever are trying to visually test it to see if they're perpendicular, you have to make that change. Okay, so again, for this question, this is the stuff you need to remember about parallel and perpendicular. So if you remember both of those, I guess you don't need to jot it down, but if you think you forgot that, then you need to add it to your notes, please. Okay, so all of these questions are similar to each other, so this would be a good time to pause and field any questions you have. Is there anything about 1 through 4 you want to get clarified before we keep going? Okay, so questions 5 and 6. I think most of you guys have probably not heard this before. These are not hard questions, but there is a couple things you have to know to be able to do these, and then they'll be pretty similar to what we did above. I know some honors Algebra 1 teachers will show you this, but even if yours did, it's not something you practice a lot. So you need to know something about what's called direct variation. There's two things you have to know to be able to work these questions. Direct variation, always go through the origin without being told. And the slope, I don't know the background to why this is, but instead of saying m for slope, we often say k. And instead of calling it slope, we call it the constant of variation. So, direct variation, the two things you have to know to be able to work those questions is it goes through the origin, and the slope is not called the slope, it's called the constant of variation. So, this says write an equation, just like we did in 1 through 4. So, I've got a point, y minus the y value equals the slope times x minus the x value. I'm almost done, I just don't know the slope. But like questions 1 and 4, I have 2 points. They gave me a point, and because it's direct variation, it goes through the origin. So, subtract the y values over subtract the x values. Looks like the slope is 2/3. So it's the same work, it's the same skills as we did up in 1 through 4. But again, you have to know that stuff that I highlighted about direct variation. That's the stuff that's assumed about it when they say that. All right, question 6 is also like this, but it's got 2 questions. It wants us to find the constant of variation, which again is sometimes referred to as k, but it's basically the slope. Or it's not basically, it is the slope, it just has a different term. And they want us to figure out when x is -2, what is y? So this is a 2-part question. So right here, they give me a point. Because it's direct variation, they really give me a second point. So if I need to know the constant of variation, aka the slope, I'll just subtract the y values over subtract the x values. Of course, dividing by a fraction's not the most fun, but Just change it to multiply by reciprocal, and then you've got the slope. You've got the constant variation. Not harder, just different term. It's almost just like a vocab question, basically. Now, if I'd like to know what is the y value when x is -2, the question didn't say I need to do this, but this is where an equation would help you. You could do y minus one of the y values. Now again, you can use either point you want to. Feel free to use this point if you want, but I'm going to avoid this one because I don't want to deal with the fraction. So y minus a y value equals the slope times x minus the x value. The equation of a line is kind of like a formula for this problem. If I want to know y for a certain x value, like this one, I can just plug in that value in for x and solve for y. Looks like it would be 36. So again, I don't think that these two questions are particularly difficult, but I know it's new for most of you guys. So when we get to worksheet 2, it'll have you practice 2 questions similar to this, but then also even the third handout, the one that I have for extra practice, we'll do even two more of these because, again, I just know it's not as familiar to you. But for worksheet 1, this is all I've got for you on direct variation. So is there any clarifying questions you'd like to ask before I keep going? Okay, then the next little section is going to be about graphing without a calculator, of course. So I would say a lot of times if it's not in y equals, just like if you had a calculator and you wanted a calculator to graph this, you know your calculator's not going to let you type it in like this. You have to solve it for y equals. So you could subtract the 2x over, and you could divide both sides by -3. Now, you know point slope is my favorite, but I still know slope intercept because it's going to be helpful in times like this. This is in mx plus b, so I know the y-intercept is -4. I know the slope is 2/3, and slope just means rise over run. So from this point, I will count up to, right 3, up to, right 3, up to, right 3. Really only takes 2 points to define a line, but if you do more points, it's a little more accurate. But that's it. If it's not in y equals, put it in y equals so you can see the y-intercept and you can use the slope and then just connect them. So I'm actually going to skip down to the next to last question because that's what it asks us to do. Change this to slope-intercept form. So basically solve it for y equals. Subtract the 2x over, divide both sides by -5. Again, just because I think you should learn to use point slope as much as possible, you still need to know what slope-intercept form is and be able to work with it. Okay, the second graph. This one should be a very quick graph if you took down the notes you needed to on the other page. Since this is x equals a number, I already know this is a vertical line, and it's the vertical line where x is always equal to 4. And that's it. No more, no less. And of course your calculator can't even graph x equals, it can only graph y equals. Well, actually, that's not 100% correct, but for the most part, it can only graph y equals. Okay, one of the days we will practice a lot more piecewise functions, but we do mix these in here for you to practice these. I know in piecewise functions, this is always one that students feel less comfortable with, and this is one, for me, that's always kind of hard to understand. Because, and I know we've done a little bit of piecewise when we did limits, but if you know how to graph y equals -4, just a horizontal line. If you know how to graph y equals 3x minus 2, slope-intercept, and you can graph y equals 2, a second horizontal line, then you should be almost done. But what we need to do is just keep the pieces of each one as it says on the right. Now, kind of as a quick little check, because this will help you catch some mistakes sometimes, I'm going to point this out right now. This f of x, this is implying that this is a function. And we know to be a function, it has to pass the vertical line test. So there's no way this could be the final answer. This doesn't pass the vertical line test, he's not a function. So we need to go back and use these restrictions. So it's supposed to be y equals -4, but only when x is equal to -2. So equal to would be a closed circle. Less than would be the stuff to the left, but not the stuff to the right. It's supposed to be 3x minus 2, but only when x is greater than -2, not including -2, so that's an open circle, and less than or equal to 1. Since the equal to, that's a closed circle, and it can be anything in between. So the stuff between -2 and 1, but not the stuff to the left of -2, not the stuff to the right of +1. The rest of that gets erased. And then to deal with the last restriction, it's y equals 2, but only when x is greater than 1. So not equal to 1, so open circle. Greater than 1 would be the stuff to the right, not the stuff to the left. So again, I really just graphed these three, kept this part of this one, this part of this one, and this part of this one, and I'm done. Although it's a little bit better to still check the vertical line test since this is a function. Notice how mine hits my graph at most once. Even at x equals 1, this is why the open circle, closed circle is important. I know at x equals 1 it's 1, not 2. And even at x equals -2, I know the value is -4, not -7, because this one's filled in, this one's not filled in. But it's not hitting two separate points, so it is passing the vertical line test. Now, of course, that doesn't guarantee your answer is right, but it would guarantee your answer is wrong. So it's still a good little quick check. But on the third handout you guys picked up on extra practice, we'll practice 2 more of these. We may not get to that until Monday, but I know you need to practice more of those, but at least that's a little bit of a reminder. Okay, next to last one, and this is really feeding into the last question, because question 12 is definitely not something you've done before, unless you've just done it on your own for a math contest or something. But for both of these questions, we really need to remember what the parent function square root of x looks like. It's the v-graph that goes through the origin. And then this has one transformation to it. -1 next to x would shift it right 1. But it's still going to look like the v-graph, just being shifted right 1. So to pull those things together, the piecewise function and the absolute value function, that's where this is going to come into play. We want to take this piecewise function and we want to change it, or I'm sorry, this absolute value function, we want to change it into a piecewise function. And my guess would be that you probably never had to write a piecewise function, so this part seems a little bit harder. This is the third question type we'll get extra practice on the extra practice handout. So before I even tell you how to do this, this has 2 parts to it. I'm going to show you an easier version the more classic example, absolute value of x. In the last graph, we talked about what it looks like. And this one's a little bit easier to see what his piecewise would be. And I'm going to color these in two different colors so you can see where the parts are coming from. Sometimes it's this line, which would be y equals x. And sometimes it's this line, which would be y equals negative x. They both have a y-intercept of 0, so you can put plus 0 if you want to. But what I'm trying to emphasize here is how this part of my answer comes from the equation. One part was the stuff under the absolute value sign. So over here, one part is going to come from the stuff under the absolute value sign, 3x minus 1. The other part came from the opposite of the stuff under the absolute value sign. So the other part of this one is going to be the opposite, the negative version of what's under the absolute value sign. Okay, on this one, we can see right here, this is where it stops being the purple line and starts being the red line. And that is happening at x equals 0. And we need to be careful that we put our inequality signs correct. So it's the red line when x is bigger than 0, and it's the purple line when x is less than 0. And I need to include one of these, not both. I don't want to include it twice. But if I don't include it on either, then there would be a circle, or an open circle here. So you need to include one or the other, doesn't matter which one. Now, for us to do the same thing over here, to think about where the restrictions are, you could make yourself a quick little sketch. Because of this minus, we know it's being shifted to the right sum. But this 3 next to the x, you may not remember those transformation rules because we haven't reviewed them this year. There's things called vertical stretches and vertical shrinks and horizontal stretches and horizontal shrinks. If you remember those rules, this is a horizontal shrink by a factor of 1/3. But that's not really important right now, so I'm not going to go into all of that. But what I need you to realize is that right here is when it starts being the positive slope, 3, and stops being the negative slope, -3. And what's special about this point, even though I don't know this x value right now, since it's on the x-axis, I know it's where y equals 0. So I could either just set this equal to 0 and solve and get 1/3, or I could set this equal to 0 and solve and get 1/3. You could do either one, but they're both in this place. They're both in the same place when y equals 0. So it's changing hands at 1/3, and then you just need to be careful that you point your inequality signs correctly. When it's bigger than 1/3, I want it to be that. When it's less than 1/3, I want it to be this. And to make sure I include this point that's highlighted, I need to include this or this, doesn't matter. But if you don't include at either point, then it would be an open circle and it's not the exact same thing. But otherwise, it doesn't matter which one you include it to. So again, I know this is one of the harder ones, so let me just spend 10 more seconds reviewing what I did. Just like this, one part of the piecewise function came from the stuff under the absolute value. One part of the piecewise function came from the stuff under the absolute value. Other part of the piecewise function was the opposite of the stuff under the absolute value. Other part of the piecewise function is the stuff under the absolute value. This was changing hands at x equals 0. I just know that because I know what the graph looks like. That was pretty easy. This one I knew it was going to the right sum, so I could kind of visualize it. But I know it's switching when y equals 0. So I could either set this equal to 0 and solve, or I could set this equal to 0 and solve. Doesn't matter. But either one is going to tell you it's changing hands when x is 1/3. And then you just need to make sure you have your inequalities pointing the right way. The red is to the right, so I wanted x to be bigger. The purple was to the left, so that's where I need x to be less. So again, there'll be one more of these for you to practice on worksheet 2. but then we'll practice 2 more of these together on the extra practice. So with a little bit of repetition, it'll get easier. Yes, sir.
3x minus 1, how did you get x equals 1/3? Why isn't it not a negative?
For this one,
Yeah.
well, you'd have to add the 1 over, which makes it positive, and then divide by 3.
Oh,
And on this one, you'd have to subtract the 1, which would make it negative, but then you divide it by negative, so it goes back to that. So it doesn't matter which one you plug it into, they should be the same. Okay, so again, I know we're not going to get through all of these, but first thing we will do on Monday is go over worksheet 2. So notice worksheet 2 looks just like worksheet 1. So you guys have about 19 minutes. So I'd like you to try worksheet 2 before you call it quits for today. And that way we can start class with it on Monday by going over that and then practicing the 3 question types that I know you'll need more practice on, and then we'll move on to quadratics.